Okay, so as I said in my earlier video, we did two kinds of correlation tests. First one we did in class was Pearson correlation, and how you do that is this is actually a formula for calculating the power of strength of correlation. The R is the value of correlation or strength of correlation. So how you do that? Sum of products of deviations divided by square root of sum of square x and sum of squares of the y variables. Why do you do that? And what is a product of deviations? Well, let's walk through an example to review what it was. Good. Suppose this is such a small example. There are only like 4 values in it, four pairs in it, and trying to calculate correlation, and it's not unrealistic. It's really unrealistic, but for the sake of illustrating how it works, that there are only 4 pairs or four persons. Okay, so suppose I want to calculate the Pearson correlation between scores on x and y for 4 people. Okay, so x, it could be a math and English or something like that in real life, and the person 1, 2, 3, 4 can be a student ID or something. Okay, and this is a scatter plot you get, and it's just like this. If you draw a straight line, you can kind of draw a straight line like this. It appears like linear, so if it's linear, we use Pearson, and if it's non-linear, we use Spearman. So because it looks linear, we can go ahead and do a Pearson correlation. And that's how you do it. But however, the question, what is the sum of products? What is products? Sum of products is calculated like this. Okay, so this is the x value minus mean of x values times y value minus mean of y value, and you sum. So product is basically this. Okay, this minus mean x times this minus mean y. Yeah. In other words, if the mean of these is 3, the mean of all the y values is 5. So okay, x minus the mean, x minus mean, x minus x mean, x minus mean of x's, and y minus the mean of y's, and y minus mean of y's, y, minus the mean of y's. Y is 4, right? So the product means this times this. So in this case, minus 2 times minus 2. In this case, minus 1 times 1. And 1 times minus 1, 2 times 2. Those are the products. And there are 4 products. And sum of products means just the sum of products. Because products, okay, let's look at okay, so these are products. So sum of products would be sum of these numbers. So that's what sum of products. So what this number represents is a question. Because these numbers are deviations from the mean, and these are deviations from the mean, and when you combine, when you multiply this, it kind of tells the size of deviations as a total. Deviation from what? Deviation from the means. So mean is that 3 and 5. So it's like a slope is like, when 3 and 5. So if that is a mean, there's a hypothetical, strength or a slope, degree of slope, and I'm trying to figure out. I think that's what I think we're trying to do. Trying to figure out, the deviations from the hypothetical correlation. Or I think what I'm trying to do is, just simply trying to get deviations from this single point, 3 and 5. It may be that, in a scatter plot, here, for example. Oh. 3, x3, and y5 is about this point here, right here. And I think it's trying to, figure out the deviation, the size of deviations from this point for each point. And the deviation size can be used as a rectangular area, like, this would be. Okay, so this is the deviation of this point is just this big, this much deviation. It can be, calculated as an area. And deviation from this point, that much deviation, that much deviation, that much deviation. And how do you, so you can kind of say, I don't know if that's the case, that's what I'm trying to do, but that's what's actually trying to, actually doing. And so areas, when you combine these areas, considering the negative field and positive field, you get the negative or positive amount of combined field, and it creates a size, and it gives you a size of total combined squares, and that's the sum of products. And you compare that, you divide that by this, and then you get the ratio. And when these values are same, then it means a perfect, perfect positive and negative correlation. And so what is this? Let's look at what that is. Okay, do that and square that, and that is the sum of square for x and the sum of square for y values. And you what do you do with that? Okay, let's see. Okay, so you do multiplication, sum of square x by sum of square y, and you get the root. Why do you do that? This was okay. This was actual deviations from the mean, and deviation from the mean, and getting areas, and combine them all. That's what it did. On the other hand, sum of square is okay, deviation from x, deviation from y. These are same, but what's different is instead of making the product, So sum of squares, these are differences, and multiplying these numbers by the same number, getting squares of these, getting the squares of that. So, and later, and times, and later get a square root. So basically it's just getting a distance. Simply equals to just getting a distance, and it's no directional. And I see. So 4 times 4, instead of doing a 2 times 2, same concept as the early examples. What it's doing is, so getting a total variations here, and I see. Basically then this number and this number turning into a square root and getting rid of the positive and negative numbers, then adding them up. In other words, see, 2, 2, 1, 1, it's like a 4, 5, 6. In this case, it's gonna be 6, you know. And there's 4. And time 36 opposed to 36. 2, 4, 5, 6, 36. 2, 2, 2. 10, 10, 100, 10. I see. Okay, this is going to be another topic for another video. Why do you do that? So when you do sum or square x times sum or square y, it's going to be 10 times 10, and it's 100, and the square root of that is 10. So in general, you know, when you square first, instead of, you know, doing this, doing that, and add them up, and, you know, add them up and doing that, which gets larger, you know. Usually the deviation is going to be larger in this, you know, doing this and that, unless the ratio between y increase and x increase is the same. The deviation is going to be caused by the slightly off slope. Okay, so in this case, you know, that's going to be 6 over 10, which is 0.6. So correlation between scores on x and y is 0.60. Positive 0.60. Okay.